Okay, so I found that partition coefficient, this is a part of solvent extraction. So partition coefficient calculations seem to be quite an issue for many students because they don't know what to put on top. They don't know what to put on top, but I'm here to help you out with that. So basically the partition coefficient is the ratio of the concentration of solute that was extracted by the organic solvent to the ratio of the concentration of solute in the aqueous solution, which in most cases water, right? Sorry about that. That sounded probably like a bag of gibberish. So let me help you a bit further. So the KD, which is the diffusion coefficient, diffusion, that sounds wrong. Distribution coefficient, or you could see it written as KPC, which is the partition coefficient. Same thing, right? It's equal to the concentration of the organic solvent divided by the concentration of water, basically. Always this way. It's similar here, organic solvent divided by concentration of water or H2O. Unless they state otherwise, this is how your equation should look, where organic solvent concentration is on top and water on the bottom. Okay, so let's look at a few examples. So a solution of P in water was shaken with benzene. So basically, you have a separating funnel, and forgive my terrible drawing, but let's say you have a separating funnel and you have water in it first. So your first layer is water and you have a solute P in water, all right? So you'll have a certain amount, probably 5 grams. Now, when you add an organic solvent like benzene to it, what is going to happen is an equilibrium will be set up between both layers. And so you'll have this 5 grams, some of it moving into the organic solvent layer, and it's usually referred to as extraction. So sometimes you'll say X and X amount was extracted into the organic solvent or simply the solvent layer, right? And so what you will have here is no longer 5 grams, but rather less than 5 grams. Let's say that, less than 5 grams. And over here, you'll also have whatever was extracted from that 5 grams in the organic solvent layer. So that's how this works. So after adding the organic solvent, you will take the concentration of both layers or find the concentration of the solute in both layers. And what you will find is the solute in the water layer, sometimes we refer to it as the mass M, and the organic solvent layer will be, for example, 5 minus M. Now, the reason why the water layer is always M is because that is what is left behind after extraction, right? So you're not going to get the original 5 grams in it. You're going to have what was left after extraction. And so the organic solvent layer will have what is extracted, which is 5 minus what was left behind, because we originally started out with 5. So I hope you understand why we'll always use M for the water or aqueous layer, and for the organic solvent layer, why we'll use 5 minus M, or whatever mass was originally given minus M. All right. For this question, though, I believe it's just a direct substitution. So we wouldn't need to apply this concept just yet. But I just wanted to introduce you to it so you can wrap your mind around it before we get to a question that requires it. So a solution of P in water was shaken with benzene, and the concentration of P in both solvents was measured, right? So the concentration of P in water was found to be 0.001 molar, which is mole per decimeter cube. And this concentration in benzene, which is the organic solvent, was 0.02 molar, which is moles per decimeter cube. So now they want you to calculate the partition coefficient for P between benzene and water. So however you write it, either KD or KPC, KD is equal to the concentration in the organic solvent layer. So in the benzene layer, which is 0.02 molar. Actually don't need those brackets right now. So 0.02 molar divided by 0.001 molar, which would be the concentration in water. 0.001 molar. So you'll find that the partition coefficient for P between benzene and water being 0.02 divided by 0.001. And that would be 20. So if you got 20, then you're good, right? Let's try another one. So a solution of 10 grams of an ester Y, and I would say pause the video and try to do them before me, right? It will help you in your practicing. So I like to highlight, and usually when I'm doing my examinations, I don't have a highlighter, so I'll just underline with my pencil what is necessary so that I can keep track of important information. For example, even when they say that they want the final answer to like 3 significant figures, I ensure that I underline that because that's the easiest thing to forget after working through an extremely long problem, right? So a solution of 10 grams of an ester Y in 100 centimeter cube of water was shaken with 200 centimeter cube of an ether. Ethers are organic solvent. An example would be diethyl ether, right? So that's your organic solvent. After separation, the aqueous solution was found to have or contain 1.6 grams of Y, so that was left behind after extraction. And then the partition coefficient of Y, they want you to calculate the partition coefficient of Y between the ether and water layer, right? So as I said, this 1.6 was what's left behind after, extraction had occurred. So then you, in order to calculate, the mass or find the mass that was in the solvent layer or the ether layer, you'll have to subtract that 1.6 grams from what we started off with overall. But as I would say, start out with your equation first, where KD or KPC is equal to the concentration of the organic solvent divided by the concentration of the water layer. So now we have to take a little extra step for our calculations because we actually don't know the concentrations of each layer. So we'll have to work that out. And in this case, we'll be working in terms of mass concentration. So mass concentration, let me just give you that formula, is equal to the mass divided by the volume, always. If it's molar concentration, then that's mole divided by the volume. So if we're supposed to find the concentration of the organic solvent layer, let's deal with water first, seeing that that's what we have. Now, the concentration of the water layer would be equal to that 1.6 grams divided by the volume of water used, which is 100 centimeter cube. You don't have to convert centimeter cube to decimeter cube because in these calculations, you'll have the volumes cancel out each other anyway. So it really don't matter. So 1.6 grams, that's easy, right? But now the concentration of the organic solvent layer is going to be equal to the mass that was extracted. And the mass that was extracted would be the total 10 grams that we started out with, minus what was left behind in the water layer. That would mean that was not extracted, right? So then that would be our mass that we'll work with. And we use 200 centimeter cube, right, of ether. So that's how we'd find the concentration of water and the concentration of the organic solvent. If you have any questions about this, just ask me down in the comments. I'll definitely be checking them this week, as well as my DMs on Instagram. I'm really trying to keep consistent with checking them. So now that we know that, we can go ahead and write our equation where Kd is equal to concentration of the organic solvent layer. So I'll just simplify that to 10 minus 1.6. That's 8.4 grams divided by 200 centimeter cube. And this will be divided by the concentration of the water layer. It's easier to put them in like this, or you could condense them to decimals and then fix them in. So you could directly put the fractions, I forgot what these were called for a bit, fractions in, or you could just change them to decimals. So if you do change them to the decimals, your number is going to maybe differ a bit. So this is 0.042 divided by 1.6 over 100. I don't know why I'm putting that in the calculator. I'm just supposed to jump 2 spaces back. 0.016. So if you divide or just work that out now, what you'll get is 0.042 divided by 0.016. The partition coefficient would be 2.625. So yeah, I mean, you could just write 2.6. I'm just being a bit extra here, but I hope this was clear. Let me just put them in my calculator one more time to just check that the answer is correct. Yeah, should always put them in your calculator at least twice. Ensure that you got the same answer twice, right? Don't just do it one time, because sometimes you can actually put it in a bit weird or miss a number. And you don't want, knowing how to do the question but got it wrong because you put the wrong number in the calculator. That's just crazy. So this and this is this. So these are what we have left, right? So we'll just go through these. These are quite extensive problems, or harder problems, if you will. So if you're able to do these, then you're well set for your exam, right? So when 50 centimeter cube of an aqueous solution containing 0.5 grams of an organic solute X is shaken with 5 centimeter cube of benzene, 0.2 grams of the solute X was extracted into benzene, and they wanted to calculate the value of the partition coefficient X between benzene and water. Then they said if the aqueous solution is shaken with another 5 centimeter cube of benzene, what mass of solute X will be extracted in the benzene when equilibrium is reached. So hold on, one more, right? Work out the first part of the question first. So find the partition coefficient. And so what we started out with was 50 cm cube of the aqueous solution, 0.5 grams of the organic solute, and 5 centimeter cube of benzene. And we also found 0.2 grams being extracted into benzene. So in that case, remember, the partition coefficient is equal to the concentration of the organic solvent layer divided by the concentration of the solute in the aqueous layer or water, right? So the concentration of the organic solvent layer would be equal to the mass found, which was 0.2 grams, in the volume used, which would be 5 centimeter cube. And the concentration of the water layer would be equal to what was left behind, which would be here, in this case, what's left behind, we started out with originally 0.5, and 0.2 was taken out. So now what's left behind would be 0.3, right? So 0.3 grams divided by the volume of water or the aqueous layer used, which would be 50 centimeter cube. So now to find the partition coefficient KD, that's equal to 0.2 divided by 5 or over 5 divided by 0.3 over 50. Can put all of this in a calculator or condense them to decimals, where 0.2 over 5 is 0.04, and divided by 0.3, I think we're going to get a large, a recurring or non-terminating decimal for this, but I'm not sure. Okay, so the calculus is 6 times 10 to the minus 3, so we'll use that. So 0.04 divided by 6 times 10 to the minus 3, the KD is going to be equal to 6.7. Now we can continue to the second part of the question. So KD, this is another constant. It is remember I told you an equilibrium will be set up between the aqueous layer. So aqueous layer, solvent in the aqueous layer will set up an equilibrium with the organic solvent layer. So the KD is actually the concentration of the organic solvent layer by the concentration of the aqueous layer. So as you can see, or I hope you remember that if you have A plus B setting up an equilibrium with C and D, then the equilibrium constant is going to be equal to the concentration of C times the concentration of D divided by the concentration of A times the concentration of B. So this is the equilibrium constant, right? So basically, this is the case or the general case for all equilibrium equations or chemical equations. So it's not nothing different for an equilibrium like this. It's just that the concentration of the organic solvent divided by the concentration of the aqueous layer is going to give you a new equilibrium constant called KD or KPC. And I hope you're focusing on the term constant. It is constant, so it doesn't change. So this is going to help us to work out the second part of the question, which says, if the aqueous layer is shaken with another 5 centimeter cube of benzene, that will now mean you're shaking it with 10 centimeter cube, because we initially started with 5, and if we add 5 more, 5 plus 5 is 10. So this is going to have you use the equation where 6.7, which is the KD, is equal to the concentration of the organic solvent layer, right? But this time we need mass, right? So the mass that would be extracted into the organic solvent layer would actually be 0.5 minus the mass that's left behind in the water layer. Remember that we started out with 0.5 of organic solute X, and what we're trying to find now is the mass M or X of the solute that would be extracted into the benzene, when the equilibrium is reached. So the mass would be 0.5 minus M. And so we'll divide that by not 5 this time, but 10 centimeter cube, and divide that by the concentration of water, which would be the mass left behind in water divided by the volume of water used, which is 50 centimeter cube. So now what we do is solve for M. So 6.7 is equal to 0.5 minus M over 10 multiplied by, and reciprocate or flip the fraction here, 50 over M, right? We can go ahead and condense this by multiplying these numbers together. So 6.7 is going to be equal to 50 multiplied by 0.5 minus m over 10m. And this can help us to further calculate. Now, I want to get rid of this denominator, and seeing that this bar means that we're divided, or this line here dividing it, means that we're dividing. In order to cancel out this 10m, I have to multiply by 10m. And whatever I do on one side of the equation or the equal sign, I have to do on the other side in order to keep the equation homogeneous or equal. So now what we're working with is 10m multiplied by 6.7 is going to be equal to 50 times 0.5 minus m. I think I'm running out of space, so I'm going to create space. Give me just a sec. Tiny, 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 and move up. I think I can make this a bit smaller because I don't think that would be a problem. So now 6.7m times 10m times 6.7 would be 67m, right? Because it's 10 multiplied by 6.7 and you just put the m after. That's equal to, now we'll distribute the brackets. So 50 times 0.5, which is half of 50, which is 25, minus 50 times m, which is 50m. Now we need to group the like terms, and what we have here is minus 50m. So I'll just try to get that on its own. So we'll try to get this 25 on its own. So seeing that we're subtracting 50m, in order to get rid of it, I'll add 50m. And remember, in order to keep it homogeneous, we have to do the same thing on the other side. So 50m minus 50m, or negative 50m plus 50m, cancels out each other to 0. So now we have 60m, 67m plus 50m, which is literally 50 plus 67. That's 117. And you just put back m is equal to 25. So now you'll divide by 117 on both sides to get the equation reading as m is equal to 25 divided by 117, which is 0.214 grams. But they asked you what was the mass that would be extracted in the benzene layer. So we'll have to subtract this from 0.5. So 0.5 minus 0.214 is equal to 0.29 grams. Could actually work this out another way and get the same answer. But yeah, that should be it for that. So I hope this one was clear, and let's look at the other one. We have 2 more, so just hold on with me, hold out, right? So the partition coefficient of X between methyl benzene and water is 12, right? So this time they did you the liberty of giving you the partition coefficient. So partition coefficient is 12, and X being more soluble in methyl benzene than water. So I should have told you this earlier, but if the partition coefficient Kd is greater than 1, then your solute is more soluble in the organic solvent. But if it is a case where Kd, I think I have this dyslexia thing going on, Kd is less than 1, then the solute is less soluble in, or more soluble, sorry. Let's say more soluble in the water or aqueous layer, but less soluble in the organic solvent layer. That's what I was going to say initially, but let's just say more soluble in aqueous layer. It means the same thing though, so it don't really matter. So yeah, if KD is less than 1, that means it's more soluble in water, or it's less soluble in the organic solvent layer, same thing. Or if it's the partition coefficient is greater than 1, then that means that your solute is more soluble in organic solvents. So they want you to first calculate the mass that will be extracted from 200 centimeter cube of aqueous solution containing 8 grams of X by shaking it with 50 centimeter cube of methylbenzene. And then they want you to calculate the mass that would be extracted from 200 centimeter cube of the aqueous solution containing 8 grams of X by shaking with 2 separate 25 centimeter cube portions of your organic solvent, in this case methylbenzene, which is also called toluene. So yeah. So let's start with the first part. Let's do the first part first, tackle that part, right? So the partition coefficient is 12. So that means KD is equal to 12. We also know that KD is equal to the concentration of the organic solvent divided by the concentration of the water layer, right? So then what we can do now is figure out where the number is going. So we're asked to calculate the mass. So the concentration of the aqueous layer or the water layer would be equal to the mass left behind divided by the volume of water, which the aqueous solution was said to be 200, right? Centimeter cube or centimeter cube. And then the concentration of the organic solvent would be 8, which would be the original, everything that we started out with, the solute, the complete total for the solute, 8 minus what was left behind in the water layer, divided by the volume of methylbenzene, which is 50. We're working this out first, right? So then if you look here, 12 being equal to organic solvent layer, 8 minus m over 50 divided by m over 200, we can go ahead and solve for m, right? So yeah, let's do that. So m, here we have 12 being equal to 8 minus m over 50 multiplied by 200 over m, right? And so 12, 12, 12, 12, 12, we can just cross multiply, or just, I shouldn't say cross multiply, but multiply horizontally. So this is 200 times 8 minus m divided by 50m. And we can solve for m just in the same manner. So we'll multiply by 50m on both sides. There are so many ways to do this, but I prefer this way. So 50 times 12, which is 600m, that's going to be equal to 200 times 8 minus m, which we're going to just distribute that right away. So 200 times 8, 200 times 8, that's 1600. And that's going to be 200 times negative m, which is minus 200m. So then you add a 200m to both sides because you want to get all the liked variables on one side, like terms on one side. So this is going to be 800m being equal to 1600. Divide by 800 on both sides. And 0 cancel 0. 16 over 8 to 8, 16. This is going to be m is equal to 2 grams, right? So the question says, what mass of X will be extracted from 200 from the aqueous layer. So what will be extracted from the aqueous layer would be what would be in the benzene layer. So that would be 8 grams minus 2 grams, which is equal to 6 grams. So 6 grams of solute X will be extracted from the 200 centimeter cube of aqueous solution. And M is what will be left behind, which would be 2 grams. So 2 grams will be in the water layer and 6 grams in the solvent layer. So how do you know that your answer is actually correct? You should have more or a higher concentration or a higher mass in the organic solvent layer, because the question told you that X is more soluble in methyl benzene than water. So you're going to find that you'll have more in the methyl benzene layer than water. If it's a case, and it's also told through the partition coefficient value, which is 12, a number greater than 1. Now remember, I told you if the partition coefficient is greater than 1, then the solute is more soluble in the organic solvent. So yeah, I'm just creating more space. So we're going to move on to the next portion of the question. And this is going to help me to go into something else that you should be able to make a comparison between. So they want to know what would be the mass if you did it in separate layers. So you're going to use the same equation where you have 12 being equal to 8 minus m, but instead of 50, you're using a volume of 25, right? So you're using a volume of 25 and you'll divide that by the mass over 200 because the volume of water wouldn't change. It's still 200 in the aqueous layer, but this time portions, 2 separate portions of methyl benzene, so 25 and 25. So we'll have to do this calculation twice. So first we're going to calculate what was extracted first, right? So this would be 12 being equal to 8 minus m over 25 multiplied by 200 m. And you'll do the same thing, condense these, or you could just divide 12 by 200 m, 200 over m, but I won't do that. I really won't, because I don't want to mix up the calculation. So I'm taking the safer route, 208 minus m over 25m. And I'll distribute these and I'll multiply by 25m on both sides, right? So 25 times 12 is what we're dealing with now, which is 300, and we'll plop the m right in front, is equal to 200 times 8. That's 1600. I think we did this already. Yeah, we did it, 200m. Then I'll add 200 to both sides, or 200m rather. So this is going to give me 500m being equal to 1600, and we'll divide by 500 on both sides to get the equation reading as m is equal to. So m is equal to 1600 divided by 500, which is 3.2 grams. If m is 3.2 grams, then what you're going to do is basically take that 3.2 grams from the 8, which was our original amount, right? Or original amount, to see what's left for extraction. So if you subtract 3.2 from 8, that's 4.8. So now you're going to do the second extraction using 4.8 grams. So 4.8 grams minus m is divided by 25, or over 25, which would be the other part of the 50. And that would be divided by m over 200. This would be 12 is equal to 4.8 minus m over 25 multiplied by 200 over m. We'll do the same thing. We've done this so many times. So 200, 4.8 minus m over 25m. Again, distribute these brackets, multiply by 25m on both sides. So 12 times 25, that's 300 M being equal to 200 times 4.8 this time. Oops, I think I just put something wrong. That's 960. And then that would be minus negative or negative 200 M or minus 200 M, because 200 times negative M is negative 200 M. We'll add 200 M on both sides. So that's 500 M being equal to 960. Divide by 500 on both sides. This cancels this. 960 divided by 500 would give you 1.92 grams, and then you'll add these. So 3.2 grams plus 1.92 grams would be equal to 5.12 grams. And this would be what you would have extracted from the water layer. Yeah, these would be, this total 5.12 grams would be what would be extracted from the water layer if you would have done it in two separate portions. So now, if you do it in one large portion, what would be extracted from the water layer would be 6 grams. Or what would be left behind in the water layer what would be extracted from the water layer would be 6 grams. Now here, this 5.12 grams would be what would be extracted if you had done it in two separate portions. Now the value for what is extracted if you've done it in two separate portions should give you a greater extraction value than if you did it in say one portion. So hold on. Give me a second. I think I need to do something. I'll just pause this for a bit. Okay, so I had to deal with something real quick, so I'm back. All right, so where was I? Oh, change this 3.2, forgot. So, all right, so we just work out this 1.2, which that 1.2 grams would be what's extracted as well. And so if we have to add the masses. First of all, do something here. This 3.2 here is the mass that was left behind in water. Seeing that we used the 4.8 here and got 1.92, what we'll do is 4.8 plus the 1.92. If you did it the other way around, you would have to then add the still 4.8 plus the 1.92. But I forgot that this 4.8 here would be what was left behind, not left behind, but extracted from the water layer. So if you add 4.8 to 1.92, then you would get 6 point some. Let me put that in. 6.72. Yeah. So 6.72. So seeing that if you put it in like larger or smaller portion, separate 25s and one large 50, then you should get a value that is larger than your, if you did it in one big chunk. If you did it in one big chunk, we got 6 grams. That's if we did it in 50 centimeter cube. But when we divided it into two parts, the 25 and 25, we got a larger extraction. So by doing it in smaller portions, that's a more efficient way of doing your solvent extractions. So this should be 6.72 grams. Nice. So the last question for now. So an aqueous solution contains 2.5 grams of a compound in 50 centimeter cube of solution, and the partition coefficient of the compound between water and an organic solvent is 0.2. They want you to calculate the mass of the compound extracted by shaking 100 centimeter cube of aqueous solution with 25 centimeter cube of solvent. Now, if we were told that in 50 centimeter cube, you'll have 2.5 grams. In 100, you'll see that 100 is 2 times 50. In 100, you'll have 5 grams. I hope that was clear. So now, if it is that we're supposed to find the KD, that would be equal to the organic solvent layer concentration over the water layer concentration. So now we can write the equation where the concentration of the organic solvent layer, let's do water first, organic solvent of the water layer, the concentration of the water layer would be equal to the mass left behind divided by the volume, which is 100 centimeter cube. And the organic solvent layer would be 5 minus the mass that was left behind. So what's extracted into the divided by the 25. They said 25 of the solvent. So nice. So now if KD is 0.2, right? The mass extracted by shaking. So you want to find the mass that was taken out. So this is 0.2 being equal to 5 minus m over 25 divided by m over 100. And in this case, what you're going to do now, 0.2 is equal to 5 minus m over 25 multiplied by 100 over m. Now, 0.2 is equal to 100 times 5 minus m over 25m. We'll multiply by 25m on both sides just to keep the equation homogeneous. So 25 times 0.2, that's 5m being equal to distribute the brackets. So 100 times 5 is 500, and 100 multiplied by negative m is negative 100m. And so we'll add 100 to both sides because we're subtracting, so to cancel it out. And so we're going to get 105 being equal to 500, 105m. So 105 divided by 105 and 105 on both sides. Cancel. 500 divided by 105 should give you the answer for m, which is m being equal to 4.7 grams. But they asked you to calculate the mass of the compound extracted. So what's extracted would be what was not left behind in the water layer. So that would be 5 minus m, and m we found as 4.7 grams because that's what's in the water layer. So 5 minus, the answer is 0.238, 0.23. So this is the mass that would be left behind, that would be extracted by the solvent layer. And it makes sense because the partition coefficient is less than 1. And remember, if it is that the partition coefficient is less than 1, then that would mean that your solute is more soluble in water. So you'll find a higher concentration in the water layer than your solvent layer. So the mass of the compound extracted by shaking is 0.23 grams. All right, so I think that's it. So I hope this was helpful. If you have any questions, tell me in the comments or ask it in the comments. And the comments is always a good place to check for things, right? So this is it. Yes, if you need to contact me for business, my number is 876-501-1966. You can follow me on Instagram at young_genius.official, or you could check out my personal business page at _CAM_EO. My name is Camille, by the way. Right? Or you could email me at younggenius.educate@gmail.com. That's younggenius.educate@gmail.com. So 2 G's, okay? So all the best. And until next time, I'd like to say bye, guys.